parent function. So if you didn't understand even and odd, it should make a little bit more sense. Okay. We're not doing all of this. We're really going to fly through even and odd because it's pretty quick. If something is symmetric across the y-axis, okay, that's where literally if you drew a line right down here and folded it on either side, okay, it would be the same. Okay, we call this an even function. A good quick check for that. If a point xy is on the graph, the point negative xy is also on the graph. In other words, the x just changes sign. Origin symmetry is something like that. We saw that today. It's the cube root function. That's called an odd function. If a point xy is on the graph, the point negative x, negative y is also on the graph. Both become negative. The third type down there is x-axis symmetry. If xy is on the graph, x negative y is on the graph. I'll move down to that real quick. X negative y is on the graph. Now, what can we say about this kind of thing? It's got symmetry, but it's not a function. Doesn't actually have, we call it x-axis symmetry, but if it's on, it wouldn't be on our parent functions because it's not even a function at all. Doesn't pass the vertical line test. Okay. We are not going to do the tables on the back, but what we do need to know from the back of this is the tests for even and odd. All right, the most important thing on this section is this box right here. A function is an even function if f of x is equal to f of negative x. In other words, if you take out your x, plug in negative x, and it gives you the same thing back out, it's an even function. It's an odd function if f of negative x is equal to negative f of x. We've done that stuff in the last couple days, but you're going to have to plug in things to see, okay? I always check if it's an even function first, and then check if it's an odd function second. If neither of those tests work, then it's neither even nor odd. Okay? At the bottom, we're going to skip these tables completely and just talk about how to do this algebraically. Okay? Because we're not going to have calculators for this, so graphing it and seeing isn't an option. All right, so for a question like 2 down here, when it says determine algebraically if it's even, odd, or neither, it means use one of those tests. And I'm going to write them here again so we can look at it. So first, to see if it is even, we need to see if f of x is equal to f of negative x. The reason I check for even first is because that left-hand side is just f of x. Do I have to do any work to get f of x? No, that's given to me. I do have to do work to do f of negative x, right? I have to plug in a negative x for that. But for even functions, I don't have to do any work for 1/2 of it. So let's set this up. On the left-hand side of that, it's f of x. So I'm making an equation for myself, and I want to see if this is equal. So on the left-hand side, I just put f of x, because that's what it says right there, left-hand side. Right-hand side, what am I doing? According to the test for even, I'm taking out the x in my function, and in its place I'm putting what? Negative x. So write the same function, but I'm going to take out my x, and in its place put what? Negative x. Any issues with that setup? I just took this even test here, and I put f of x on the left, and I put f of negative x on the right. We are going to simplify on either side if we have to, and see if it is going to be the same. Is there anything to simplify on the left-hand side? Nope. On the right-hand side, if I cube a negative x, what number's in front of that x? Negative 1. So what's negative 1 times negative 1 times negative 1? -1. So when I work that out, it becomes this. Are those the same? No. So what does that tell me about this function? Not even. I probably would have guessed it wasn't even. Why? It's a cubic. It's an odd exponent. My guess would be that it's not even, but that's just me. To see if it's odd, and I'm just copying this down from the top box. What's the test? F of -x is equal to -f of x. Now this one, the reason I choose to do this second is because you have to do something on the left and you have to do something on the right, right? You have to plug in -x on the left and you have to plug in negative out front on the right. Now, what could you do if you wanted to shortcut this for yourself? We've already done that right there, right? What did that turn out to be for that first function? (x⁻³ minus 4. That was this. We had already simplified that. And that's the other reason I do odd second, because we did part of the work to do even. So you might as well use it. To do the right-hand side there, what is this telling me to do here? Take your function and put what? A negative out front. And do what with it? How do I simplify that? Distribute the negative. That's going to give me (x³ what? Plus 4. Are those the same? No. If neither are the same, that means it's not even, it's not odd. And your answer just would be, it is neither one. It has no symmetry. This, for some reason, usually is one of the tougher things we do, not because the math is hard, because it's difficult to understand what you're supposed to do sometimes. Let's try that again with 3. A different function, f of x. If I want to test if this is even, how do I set up my even test? What do I put on the left-hand side of my equals? F of x, that's the absolute value of x. On the right-hand side, what do I do for even? Absolute value of (x). What does absolute value do? Takes away the negative. So what does that tell me here? This is equal, which means what is this function? Even. Questions on that one? All right, again, we go through your even test first before we do odd. So for 4, if I'm setting up the even test for number 4, what do I put on the left-hand side? Your equation. On the right-hand side, according to the even test over here, what do? Take out my x, and in its place, what? Put in (x). Now, this one you got to be careful. What's out front of your x³ to begin with? A negative. So when I plug in (x), the negative goes outside and a negative goes inside with x, plus another (x). Okay? On the left-hand side, I do not have to simplify this. On the right-hand side, when I cube a (x), what does it give me? Negative, but the negative out front makes it positive (x³). Plus a (x) is just minus x. So our question is, are those equal? Nope. So what's that tell me? Not even. To check if it's odd, I use the other test. On the left-hand side, we do f of (x), which we already know the answer to. What did we get for that? (x³ minus x), this stuff on the right. That's what that is. On the right-hand side for this test, what do? Put a negative on the outside of which function? The original one. Always go back to the original for that. And distribute that negative. When I distribute the negative, what is that going to give me? Are those equal? Yes, which tells me this is what? Odd. All right, shall we practice again with that, or no? We're good, we're just done for the day. That's fair enough. The second part of your homework then for this is on page 166 and 167. Three through 8. It's literally just those kind of questions. Okay? 3 through 8. So 1 through 6 on the previous page, 3 through 8 on this one. And that is it.